Greetings, welcome. I'm Ken, and this is results-oriented preparation. Remember our motto: early preparation equals excellent results. Okay, we are continuing today with analytical geometry, and straight into our question. ABC, this one A, B, C, D is a quadrilateral with the vertices 5 and 1 for A, B is -3 and 5, C is -1 and -5, D is -9 and it's 9 and -7 there, 9 and -7. All right. Now let us attempt to answer questions. The first question, 1.1. It says calculate the gradient of AC. We want to find the gradient of AC. All right? The gradient of AC there, which is MAC, is going to be equals to YC minus YA divided by XC minus XA. All right? Now the A and the C, to show exactly which one is our Y2 as well as which one is our Y1 there. All right, now moving forward there, do your substitution. You've got YC there being -5. All right, your YC is -5 minus 5 minus 5 minus 1. All right, -5 minus 1 divided by your XC there is -1 minus 5. All right, so -5 minus 1, this will give you -6. This one -1 minus 5 will also give you -6. So our gradient there is a +1. All right, so the gradient of AC is equals to 1. All right, and then we move swiftly to our second question, which is 1.2. Now in 1.2 says determine the equation of AC. All right, now that we've found the gradient, we need to determine the equation of the line AC. All right, of course it's not drawn there, but we know that if we were to draw a line joining the points AC, will have a straight line there. So we want the equation of a straight line in the format y is equals to. All right, now that we've got the gradient, the easiest way to go about it here is to have a 1.1 equation of AC. All right, we'll have y minus y1 is equals to m open bracket x minus x1. All right, now choose a point, any 2 points that you will use. Okay, we can choose the point at A there. So y minus y1, we know that y there is 1, is equals to m, our gradient, we already found it to be 1 there. And then we've got x, and then our x1, x is -5, close bracket. All right, so for y then, you'll have y is equals to, bring the 1 that side, this is x times 1 will give you x. All right, and then 1 times -5 is -5, -5, the 1 coming that side plus 1. All right, so y is equals to x minus 4. All right, so the equation of the line that joins points A and C, having a gradient of 1, will be y is equals to x minus 4. All right, now in this case, it's easy to use any of the points. If you wanted, you would have used the point -1 and -5. still the answer that you would have got will be the same. All right. So remember, you can use any of these 2 points. Using any of these 2 points will guarantee that you have the same answer there. Okay, so we move on to the third question. Sorry, this was 1.2. We move on to the third question, which is 1.3. Let us make space here. All right, if we move to 1.3, the question in 1.3 says, hence or otherwise show that the midpoint M, of BD, midpoint M of BD lies on AC. All right. What we want to do is we want to prove that this midpoint of BD also lies on AC. All right. That if we're to draw a line here, it will pass through M, and it's also the midpoint of BD. All right. So that is our task in this case. We want to prove that the midpoint of BDM also lies on AC. All right. So what we need to do first and foremost is we need, in this case, to calculate the midpoint of BD. Okay. Midpoint of BD in this case is going to be M, a capital M, is equals to, we know that this is x1, or we can start always x2 plus x1 divided by 2. All right. Okay, just bear with me. x2 plus x1 divided by 2, semicolon, y2 plus y1 divided by 2, close bracket. All right. Now the reason why we're dividing by 2 is because it's a midpoint. Okay. So let us take our points. Our points there are for x2 BD. All right. So we've got -3 and 9. All right. So -3 plus 9, or if you want, you can say 9 minus 3. It will still give you the same answer. All right. Semicolon. Y is 5 minus 7. 5 minus 7 divided by 2. Close bracket. All right. This one will give you 6. 6 divided by 2. 6 divided by 2 is 3. All right, that one will give you -2 divided by 2 is -1. All right, so we know that the midpoint of BD, that point, is on coordinates 3 and -1. Now what we need to do is we want to prove that the midpoint BD lies on AC. All right, what we can use there, use the equation of the line AC. We know that the equation of AC is equals to Y, the one that we just calculated in the previous question is Y is equals to X minus 4. Is it? Y is equals to X minus 4. So what we'll then do is substitute any of these. To find Y, if we substitute X there, we must get that. If we substitute Y minus 1 there, we must get this one. All right. So that will prove that this point not only lies on BD but also on AC. All right. So Y is equals to, substitute the value of X, which is 3, and then minus 4. All right. We know that 3 minus 4 is minus 1, so y is equals to minus 1. You see, y is equals to minus 1 on midpoint BD, and y is equals to minus 1 when you substitute into the equation of AC. Again, x is equals to 3 on AC, and then x is equals to 3 on BD, which is point M there. So this proves that point M, which is the midpoint of BD, lies on line AC. All right. So let us move on again to the next question. In this case, it's going to be 1.4. Question 1.4. Now, question 1.4 reads as follows. Show that AMB, show that AMB is equals to 90 degrees. Show that AMB is 90 degrees. Show that AMB is 90 degrees. All right. Now, what we want to find is this. AMB is 90 degrees. So the easiest way for you to do that is to find the gradient of MB and the gradient of AM there. All right. Now let us first find the gradient of AM. The gradient of AM, we are going to check the 2 points. You know we've got YA minus YM divided by XA minus XM. All right. Okay, going further, this one is 1 minus, we know that on that one we found minus 1, is it? We found minus 1 for point M. All right. So it's going to be, instead of minus, so it's going to be plus 1 divided by x is 5 and y is x is 3 and 5. So it's 5. Sorry, let's try and be clean a bit. It is 5 minus 3. All right. Okay, so you see 1 plus 1 is 2. 2 over 2, which is equals to 1. All right. So the gradient there of this line is 1. Now for us to prove that the two meet at a right angle or they are perpendicular to each other, then we need to also find the gradient of BM. All right. Find the gradient of BM or MB. Again, there we're going to say y m minus yb divided by xm minus xb. All right. Let us substitute. We know that that one there is an error of 0.3 and minus 1. All right. Come here. This is minus 1. Minus 1 minus 3. All right. Minus 1 minus 1. Minus 1 minus 1. All right. And then the x values is going to be 3 minus 5. All right. 3 minus 5. Okay. Or rather is 5, yes. Sorry for that. It's 5 minus 3. M there is 3 and 5. Okay, minus 2. Okay, 5 minus 3, which will give us minus 2 over 2, which will give you minus 1. All right. Again, the last thing is we know that gradient of AB gradient of MB times the gradient of AM is equals to minus 1. So 1 times minus 1 will give you minus 1. So that proves that the two meet at a right angle because of that, right? If you multiply the gradient of two lines that meet at a right angle or that are perpendicular to each other, they must give you minus 1. So the gradient of MB times the gradient of AM is equals to minus 1. All right, I hope you enjoyed that lesson. Send many questions and then we'll take it from there. All right.